All right, so let's welcome Professor Vivek Choudhary. He's from the College of Business at NTU, Singapore. We are very fortunate. He was visiting India and he happened to come to Ahmedabad and visit us and give this talk. And today's talk is on nudging drivers to safety, evidence from a field experiment. You can imagine this problem is quite relevant for India. Particularly, we know that we have a significant amount of fatal accidents on the highways. And what is interesting, I was talking to him a lot yesterday about his real interface with the technology partners and how he could leverage them, convince them to really pivot their technology solutions towards making drivers safer. And that's fascinating because it has a significant relevance for India. And we can also think about how can we leverage some of these insights for other modes of transport and not just for passenger cars. So a bit about Professor Vivek Choudhary. He's assistant professor at the Nanyang Business School. He's interested in empirical operations management problems, and his broad themes lie in the intersection of behavioral operations and the supply chain management. His recent works examines the implication of technology and behavior and devise interventions to improve conduct and performance. He employs econometrics, field experiments, and machine learning in his research. He completed his PhD from INSEAD, and I have been knowing him from his PhD days, quite inspired by his work. And before his doctoral studies, he also had a stint in corporate. He used to work with McKinsey and also at ITC Limited. He holds both a BTech and MTech from IIT Kharagpur, and he also advises several startups such as Raxel Telematics. So without much ado, let's give the floor and the Zoom to Vivek. Thank you so much for visiting us, Vivek.
Thank you so much. So, is this an appropriate place to? Yeah. Okay. Okay. All right. So thank you so much for having me. And I was delighted to see the campus. I have always heard about IIM Ahmedabad, but I've never had a chance. So thank you, Devjit, and thank you, Avi, for making it helping to bring me here. And I had a wonderful dinner with Devjit yesterday. We were talking about possible potential collaboration. CTL is basically doing amazing work, and I feel that over time it is going to be doing very impactful work. So without any delay, I want to talk to you about the research paper on nudging drivers to safety. And it is a joint work with my advisor, Sergey Netesen, co-author Masha Shunko, and our industrial collaborator, June. You will be delighted to know that this paper, the field experiment, was done in India. So let's go deeper into the problem. Before I start, I want to apologize that I'm going to share with you a gender-biased example. So, wait, how does it work? I think this doesn't work. No worries. Yeah, thank you. So I want to apologize for the gender-biased example. So men in this room might have seen a bug printed on the urinal bowl. And I'm giving you this example not because I'm fascinated about this, but this is how I got introduced to the concept of nudge. And when I looked at this printed bug printed on the urinal bowl, I used to think, what a bad branding exercise somebody has done. Right. But later on, I realized through this book that this was there for a reason. It basically helps aim better, reduce splashes, and as a result, the bathrooms are cleaner. So one of the things that nudge does is basically help makes you make a decision on the right direction without forcing you. So it's basically subconsciously affecting you to make the right decision. Now we are nudged every day, and you'll be surprised how much time we are nudged. So this is one example that I wanted to show you. So I worked in factory for 5 years for ITC manufacturing different types of products. And this is called shadow boards. So shadow boards are used as a tool to nudge the workers to put back the tools after using in their right places. So if something is missing from here, you know, in a shop floor that something is missing. So this is called shadow boards. Many places, when you enter the premise, your subconscious decides how you work throughout the day. And many factories puts this kind of shine boards, which tells how many days you have gone without having any accidents. And it helps people feel about safety and being very careful in the workplace. The third example that I'm going to show you is actually my favorite. It is done on Iceland. In Iceland, what they found, by the way, this is an actual photograph. This is not any 3D or this is an actual photograph of an intersection. What happens basically, Iceland, they found that near the intersection, drivers will not wait if there are no stop signs. And as a result, intersections are prone to accidents. And since in Iceland, the driving speeds are much higher, so making a course correction near the intersection is not great. But we drive very subconsciously, and which is the topic of our talk today. If you print these kind of 3D zebra crossings, invariably people will start slowing down as they start approaching the intersection, and the lot of accidents were averted. So I wanted to, so if you have any questions throughout the talk, please stop me and ask me any question that you have. So the last example is basically based on driving, how to improve driving behavior through nudging. And that is what is the topic of the talk today. So in this paper, we attempted to improve driving performance using nudges in a field experiment. And let me show you one of the papers which produces basically annual report of the accidents on the road. And this is one there on the cover page, which describes how we feel about our driving and how others drive on the road. So driving is one task where if you ask in a class, for example, here, if I ask how many of you drive badly, not a single person is going to raise their hand. And in driving, basically, we are overconfident and it's a subconscious process. So we are hardwired when we're driving. We consciously don't take basically effort to think like, now I should accelerate, but it happens automatically. So as a result, driving is also a difficult task to change the behavior. So why should we care about driving? So driving is, if you look at, it is a core activity for almost every supply chain. And it is a new challenge for city planners. 11% estimate is given by WHO that 1.5 million out of that 11% could have been avoided because that happened because of human factor. And as a result, you can imagine the amount of lives we can save by making driving behavior better. Recently, I came across these new models, Zepto and other, which are like quick commerce. And I was talking to one of my friend in Mumbai. He is basically the head of traffic in Mumbai. And he mentioned that now most of the accidents are happening something to do with delivery. So either it is food delivery, whether it is grocery delivery or some sort of delivery. So delivery and quick delivery are going to be a big challenge for the policymakers. And gig economy, for example, in China, you can get a coffee in 5 minutes. That there are a company which says 5 to 8 minutes, I'll give you a hot coffee. So imagine the kind of driving behavior that you expect from the driver to reach. Because if you don't reach on time, your incentives are tied with that coffee reaching hot and getting a good feedback. Otherwise, you're going to miss the incentives. So you're going to rash drive just to make that incentives. So it is basically incentive based on deliveries or number of deliveries is going to be a big challenge for the policymakers as well as for us. Now, as I explained you earlier, that since driving is a subconscious process, it is hard to change this behavior because it's a complex task. It takes a coordination between eye, hand, legs, everything, and you do all the decisions subconsciously. So as a result, if you look at most of the insurance companies, they will charge you less premium if you have more experience in number of years and you have not made claims for a long time. And then drivers are overconfident. I'll talk to you about that. So there are idiosyncratic definition of what is a good driving. So AXA did a survey worldwide and they asked what is a good driving. So many people responded that if I jump the red light without hurting anyone, that is a good, like that is basically the driver is very skilled, but the result shows otherwise. So drivers are overconfident. There are idiosyncratic definitions of what is a good driving. As a result, basically, it is very hard and difficult challenge. So improving driving is not only challenging, but it is also a core of policymakers. So government has imposed regulations, for example, speed breaks and speed limits are there in many roads to reduce accidents. And you'll see that what practitioners are doing, for example, if you look at Rivigo, Blackberg, of the like companies like that, they provide feedback. And one of the problem with feedback is that this paper, if you have a chance to look at this, this is called, this is a meta study of in 1996, although dated, but it summarizes the all 5 decades of work in feedback. Feedback is one of the natural things which comes as a improving performance. So if you go to any company, how do we improve performance? There are only 2 levers: either provide feedback or get them incentives to improve, right? So these are the 2 levers which are used for improving performance. And in what we found in feedback literature, that not only positive, 38% of the time feedback actually makes you perform worse. Can you believe it? Like more than 1/3 of the time feedback actually not only, it doesn't only not help, but it actually makes you worse. And we thought that, is this something true? So we started looking at driving. So we did a previous study which was on UBI, and we found that in driving context, even if you pay people to drive better, people actually, people who took feedback and drove, they perform worse. And one of the reasons we felt is, since drivers are overconfident and we drive subconsciously, if you start consciously making changes in your driving pattern, it can hurt your driving performance. Monetary incentives. This is one favorite tools for practitioners as well as us. However, you remember, like, it is not sustainable for firms in long term. So they give you discount in terms of insurance premiums, but not beyond that. So imagine if you are a driver from Zepto, they cannot keep you paying extra money for driving safely. And lastly, there are some literature which shows that it may backfire. Now, one interesting story I wanted to share with you. So one of the company, I was telling this story to Devjit yesterday. So one company made a very nice incentive system that if you drive this much per liter, so if you get this much mileage, we are going to pay you this much extra incentive. Because if you drive safely, your mileage or per liter kilometer also increases. So what happened? They found that more than 50-60% of the drivers are getting the incentives. And they were curious that how is it possible that the near misses and insurance claims did not go down, but everybody is getting the incentives. So they found that what happens, basically, drivers which are very near to making that, they will top up their petrol tank and then they will match the mileage to get the incentive. So this is a kind of place where you'll find that it may backfire. So it did not change anything, but it actually make them better to drive worse. So this paper, basically, in driving, this is a MSOM paper we wrote earlier, where we wanted to study feedback in the case of driving. And we found 2 things. Immediate feedback reduces performance, and it actually reduces your inter-accident time by nearly 1 year. So this is a large effect for InsurTech or insurance companies to care for. So basically, they will see the queue of the claims 1 year earlier, so which is not good for them. So this feedback effect on negative performance is actually quite substantial. Second, incentives were not very important or very strong in affecting to improve driving behavior. So I'll stop here if you have any questions. If not, then I'll put, yeah. Yeah, so I'll show you the app because we use the exactly same app to run the experiment. So what happens? So it happens, by the way, just to give you a short answer, it happened just right after the trip is finished. So you'll get your feedback after every single trip. Yeah.
Was also penalties prior in order to change or improve the behavior, or were there only incentives?
You are thinking 10 years ahead in time. So UBI is one of the places where UBI is very highly penetrated. The insurance market is Italy. And in Italy, they started with the adoption phase where they wanted more and more people to share data about their driving behavior and claim the insurance benefits. So that phase has gone. So now that the penetration of UBI is extremely high now. So now they are starting penalizing. In fact, they are removing drivers who are extremely bad in driving from their platform. So if you basically drive, let's say on a scale of 120, you will not be even allowed to participate in any insurance
This is that fear of loss is higher than the hope of gain.
Yeah.
So incentive is about gain.
Yes. That's true. So initially what has happened, basically people were not ready to share the data because it collects your GPS data. So the companies know where you're going. It also knows that you're giving your driving score to someone, which can be shared with other companies. So if you're taking an insurance with company A, they may not share with B right now in a traditional sense. But if you give it to a platform, that platform may work with multiple insurance companies and they can share. So there was a lot of these pushbacks on. So for the adoption part, they give huge discounts. If you score 95 and above, they will give you up to 25% discount. Can you imagine, like 25% discount? If you are a UK driver, a young driver pays sometimes $3,000 for 3,000 euros for insurance if you're completely new and young. So imagine 25% can give you a good amount of money to enjoy. So you're right on point. Yeah.
With respect to incentives, I think in Indian truckers' life, the incentive is a major player where they're almost every day they are incentivized for being on time or being early. Same way, they are also being awarded by the owner that the luggage for whom he is carrying.
Yep.
So that is the ground situation what I have seen. So anything on that? Yes.
You're absolutely right. So I worked for ITC and I did a little bit of their warehouse management for finished goods. And you're right, like if you send a truck finished goods, let's say it's Deepavali, and you want your new product or Deepavali promo to reach the store, you'll keep chasing the driver every 30 minutes that where are you reaching? And drivers, and sometimes you'll say that if you reach early, I'll give you 500 extra. Let's just do that. And you'll realize that some companies like Blackbuck and Rivigo and now even ITC started now doing double driver. So instead of pushing the same drivers who basically invariably won't be able to take adequate rest. For example, the literature says that every 2 to 3 hours of driving, take 10-15 minutes of rest. And then you should take at least 8 hours of full rest before you take the other. For example, if you go to railways give you at least 8 hours of rest between two trains. So idea is basically if you talk to these drivers, you will realize that as I mentioned, number of deliveries for the gig economy is same applies here. So we need it even more that if there is an accident, and by the way, the trucks that you mentioned, let's say it is an FMCG good. There is an accident, nothing happens. So I attended a consortium of companies which has basically they work on industrial gases. There, if you make one accident, you cannot imagine the amount of fine you will get if a hazardous gas leaks. So there you don't want people to drive rashly at all. Late is better than, so it depends on context to context. But you're right, in driving, one of the things that Rivigo, for example, did is they tried to implement driving behavior softwares they started. And they found that driving behavior is not only related to safety, it is also related to the life of the truck. The maintenance goes down. The driver is taking better rest. It's also an indicator of whether the driver is healthy and it's good for him to drive or not. And it also helps the companies to make basically predictable time to reach, because in these cases, I can tell you, I can bet you, whenever you're calling the driver every 30 minutes, it is not a sustainable business model, right? So you're right. I think you pointed a very good thing there. So I hope I answered your question, but there is no solution to that, by the way. Like we have to implement, but good behavior in drivers. So bad planning sometimes results in rushing the driver for the last minute. I think good planning is also required other than the behavior. So let's not focus only on the driver's behavior, but yeah, but you're right.
How are we measuring driver? What are the factors?
I'll come to that. You're 2 slides ahead. Yeah. So basically we said if feedback and incentives are not working, can we do something? So we came with an idea of nudges from behavioral economics. And look, I'm not a proponent of nudge, but we wanted to try it here. One of the reasons is we only saw one Kenyan study where they put a nudge to complain if the driver is driving rash. They put 4 or 5 stickers on the drivers outside that if this driver is driving bad, please call this number. So that is one study that I found. Other than that, when I was looking at the literature, did not see many studies in using nudge in a field experiment setup, particularly for passenger cars. So informally, what is nudge? So I'll just give you a very layman term. Basically, it alters people behavior in a predictable way without forbidding any options. And nudges are basically not mandates. So for example, in IIMA, let's say the director or the faculty feels like, let's promote good food or healthy food. So if you ban junk food from the campus, that is not a nudge. But if you put keeping the fruits, vegetables, and calorie intake in front of the counter, that can be construed as a nudge. So nudges are not mandates. Another thing which is very important is nudges are costless, meaning basically they implementing those should be very cost effective. And even if you avoid that, it should not cost you a lot. It should not create any penalty, basically significant penalty. So basically cost is cheap to implement and cheap to avoid. So in layman terms, basically nudge is a gentle tap towards the right direction. That's all. And if you are interested, I can send you like a lot of examples of nudges. Other than the toilet examples, there are many things are happening right now. So nudges are different. As I was mentioning, that government are imposing regulations, companies are looking at feedback and monetary incentives. And the nudges are different because they are not mandates. Second, it is not only feedback, but what to do with that feedback. So it will tell you like, what should you do with this information? That is the difference. And they are inexpensive in both implementing as well as if you avoid that. So let's say if you don't follow the nudge, whatever is asked to, it's okay. Like you'll not be penalized significantly, right? So I'll share with you. So this is where the technology part comes in. And I'll give you a deeper understanding of this one. This is very interesting. So this is a typical telematics app looks like. You'll see there is a number called 77. That is the basically overall driving score. And once you install the app, what happens basically, drive. Why it is important? Because the company wants to very clearly know who is driving the car, because one phone can be shared with someone else or somebody else is holding. Then also they want to know that who is driving the car. It's very, very important. What you can do is you can take the insurance and give it to your friend, for example, who drives better, but that's not the idea. So it is very important. If you look at Kaggle, by the way, have you heard of Kaggle, right, for competition? So Kaggle launched a competition on creating drivers. AXA sponsored that, how to create driving signature. And basically it takes the GPS data, and apparently like a fingerprint, everybody drives very differently. Their pattern of taking accelerations and brakes and navigating and turning, everybody has a very different combination. So we can create unique signature for individuals. And I was telling this to Dev just a few minutes ago, and to sir, like in Italy, this driving signature is used for a different purpose. So if your car gets stolen and the driving signature doesn't meet, you'll get a phone call that, are you driving drunk or somebody else is driving your car? So this is what happens to create a signature. Now, after you have installed the app, it has created the signature. What it is going to do is going to, every time you finish a trip, it is going to receive an immediate feedback as a trip notification. It will just show your driving score was 60, 70, 80, whatever is the number. And then you can click on that and it will show you different dimensions in which why you got 80 score. And I'll tell you, there are 5 factors which are used for creating the driving signature. So here, this is maneuver, this is speeding, driving time, and mileage. So I'll give you one by one. What does it mean? So maneuver means basically how many sharp accelerations you have done, or how many very fast braking or very harsh braking you have done. So that comes here. Speeding means what was the speed limit of the road, and on that road, how much proportion of the time you have basically violated the speed limit. And the third one is driving time. Driving time means, are you driving in a congestion hour or accident prone hours, or are you driving in a more safer hours? And the last one is mileage. Mileage means how long or how many kilometers in a month or you drive, expected to drive. So basically, the more time you spent on the road, more time you're risking yourself for an accident. So giving these 5 factors, this driving signature is calculated on a scale of 0 to 100. Now, this is an interval of 20. So I hope I answered your question. Now, ideally, we wanted this to be continuous, but this is how most of the apps are divided like 0, 20, 40, 60, 80, 100. And calculate using a proprietary algorithm, but these are the factors which goes in. They do not. No, driving signature is your fingerprint. It only detects if you are driving or not. That's all. No. So that is only for the first 5 trips. Based on this, and also, like, there is one more thing which is missing here, is basically your GPS, like how you drive, basically how the GPS, I can press your GPS and figure out how you take the turns, for example. That will go into the but by the way, many companies now use turning, like if you are taking sharp turns, that also comes in maneuver. You're right. But yes, you said it right, that these factors, except the driving time and mileage, these factors, particularly maneuver, goes into the signature, driving signature. And so what are the things which are very interesting? So review strip scores on several. So what you can do is basically, if you got a score of 80, you can open the app and check where I am. So sharp acceleration, harsh braking, time of the day, speeding, mileage. You can also do one more thing. So app records the application usage behavior. For example, are you even opening and checking the app or not? Are you taking any feedback or not? Because if the notification is coming, you can always discard the notification. If you're an iPhone user, by default, notification will be off. In Android, it is by default on. So what you can do, we can see if the screens are visited. And this is how we know if the person is taking feedback or not. This is very interesting. And how did we send the nudges? So what we did is we sent the nudges, which are as notification and in-app messages. So basically, you send the notification, and if you discarded the notification, there is a section of messages where it will be always there, and we can check whether the person has opened the app and seen that or not. So we talked about nudge so far. We talked about the performance measure and how it is basically captured. And let's look at the intervention design. So our intervention design, which is basically on a nudge, how did we design it? So we look at behavioral foundations of goal setting and nudge theory. So one of the key understanding from behavior literature is, if you want to motivate people, give them some goals. And you can, and this is very simple, but this is very powerful. So any goal setting literature says, if you give goal, people try to strive to do that. And then there are like, how do you set the goals, how big the goal should be, how difficult it should be. There are a lot of literature on this, but basically motivation we can't measure directly. So we measure motivation through goal setting. Then we use 3 intuitive performance self-reference points. Now, look, we are at the end. The drivers are not academicians. So we have to design something which they understand very easily. And also we have to publish, right? So we have to also make it convince our referees also. So what we look at, personal average performance, like average performance, very easy to understand, drivers can understand. Personal best, they can understand. Now, how did we go about personal best? We looked at sports literature, and we found that there are a lot of motivational papers which are how to motivate like sportsmen or sports women, and we found that personal best is what they try to beat, particularly if they are already doing very well. They want to beat their personal best. So basically they are competing with themselves. The last one is basically your latest performance, and this we took from news vendor or behavioral operations model, operations management experiments, where basically if you're a news vendor, you placed a demand, how much you made money, you can see from your previous round, and so on and so forth. So these are the 3 intuitive performance reference points we used to make the nudges. By the way, we use self-reference points. And can anybody guess why did we use self-reference point? Why did not we compare the drivers with somebody else? Any guesses? Yes?
Because it is the individual whose performance we are checking.
Yep.
So if he is changing his behavior every time, there is something wrong with the driver. See, say he is overspeeding. One day he is driving good, one day he is like changing his driving pattern. So he could be drunk and drive. So we can take a reference from his last driving.
Yeah.
So what is his mood and
yeah. So this, you're right, but there is another reason. So when you are in an organization setup, let's say you're in IIMA, I can compare you to your colleagues. But if you're a driver, if you compare me to some drivers in Himachal, I'm in Chennai, how does it even matter? Right. So what happened? So what happens basically, we found that when you're not in an organizational setup, putting self-references are stronger. And we also found some evidence that if you're not in an organization, self-reference put more intrinsic motivation rather than comparing with somebody else, putting a social reference. So the other reference points, what we can use is a social, like you are on an average, you are doing like 50 percentiles, but I don't know other drivers, like who are these people. So we found that from sports, and look, we are doing a field experiment. So another thing which we have to be careful, that when you're doing a field experiment, you're going to spend a lot of money. So you want to create an intervention which can have possibly the highest impact. So what we realized that to make it clean,
Yeah, but can you do something like, among the drivers in Ahmedabad,
Mhm.
you are
yes,
doing so and so on, like this fish built and apps connects to your friends,
Yeah.
using your Facebook or whatever.
Yeah.
Among your friends and network, you are
right.
better than so many.
That's a good point. So after this experiment, the company actually brought the social driving one, and it failed miserably. So basically people will, until unless you put some bets there that who is going to score the highest in next week, what we realized that it didn't work that much. So what we realized that this one was, we found that this one was a good starting point, cleaner. And then social referencing, the company tried themselves, and as I remember, it did not work that much, because you need to put money, and then the friend. So inherently, if you ask you to make your friend group, then in driving, like how many friends you'll get, like in some places you don't even drive, in some places you drive. So this one we found that this was easy to implement, and but you have a good point that social references can work, but we found that in literature self-referencing was more important to bring intrinsic motivation, because intrinsic motivation will last longer. Extrinsic motivation will start, but you remove the friends, you remove the game, it goes away. So that's is one of the challenge we face. Yep.
Then the 4 would be multiples of 20. So what happens if the person scores 100?
Oh, so it is basically trip score. So it will be average out, and then it will be a weighted average of the distances. So I'll come to that. So the performance that we look at is trip score. But if the score is 100, you can always drive today 100, but next day you can drive 20. It's up to you. Because driving, one thing you remember, driving is not only under your control. You also drive based on what the road conditions are. So today, if you drive 100, you may not be able to do 100 just because the traffic is bad or somebody else is driving rashly. Yeah, but overall, the insurance companies, what they do is they give you this app for 3 months, and then they take the last month's aggregated score. And that is the score that matters. So you can do 100, 20, 30, but on an average, I aggregate. And for aggregation, sometimes they take the distance travel. So if you're making 100, like 100 score on a 1 kilometer trip, and then you're doing 80 in a 5 kilometer trip, then they will take the weighted average and then give you a score. Yep. Lastly, so we nudge users. So the point was very simple. We nudge users to beat their reference points. That's all. So your personal average is this, try to beat it. This is your personal best, try to beat it. This is your last performance, try to beat it. Now, we have 2 fundamental questions in this research paper. One is, first, can we improve driving performance using nudges, which is basically, we are not forcing anything. We're just telling beat this. It's very simple. We're not paying them. We're not doing any big gamification. And second, what is the relative strength of the nudges? So we looked at the characteristic of each nudge. So if you look at personal best, it is aspirational. So even if I do 80 today, even it comes out of, let's say, by chance, so the road was empty, I went for a 5 a.m. trip and I scored 80. That will become non-decreasing and very hard to beat. So every time you won't be able to beat. So try to beat it, try to beat it. It will be there. But it has a low variation over time. So the reference point will be like 60, 80, whatever is the number, that will have a very low variation. And second, if you look at personal average, it is easy to attend. It's a realistic sense of performance and some variation over time. The last one is can be difficult or easy to attend based on what did you do in the last. Like if you do the 100, cannot beat it next one. You can only match it. So, but high variation over time. Why I'm talking about variation, I'll come to that. That's the one concept. Yeah. We did it for in general. Any person. So the only so there were two criteria. One, it should not be you driving for Ola, Uber, or any. So we did it in India. It has to be a owner has to drive the car. And the idea was, how did we make sure it happened? So the company asked for, so we paid them money to install the app and keep it for 6 months. And it was very small amount of money, by the way. It was 1,500 rupees, Indian rupees. But people wanted to know their driving scores, how do they drive? And they kept it. And as a result, what happened, basically, after they have finished the stint, for claiming the money, they had to upload their license and the ownership documents. But this was one of the conditions. So if you're driving for ride hailing company, you're not eligible for the experiment. And we found that from the literature that we expected personal best to be greater than equal to personal average and then last score. But all three should have performed. That's why we kept all three treatment conditions. So let's say this green alien is, let's say, driving. So let me give you an example, like how it looks like. So let's say this green person has a past trip score of 20, 60, 40, and 60. So personal best is 60, personal average is 45, last score is 60. Very simple. So if you're a part of the personal best nudge group, what you're going to see, you're going to, and you get a next trip score of 40. So basically you scored lower. So it'll say your safety driving score was 40 recently, which is this score. Aim to beat your personal best score of 60, keep progressing. And then next trip was is 80. So you beat your personal best. So your safety driving score was 80 recently, you beat your personal best score of 60, keep progressing. So this was basically the messages which will go as notification. Yes, ma'am. No, so I'll come to the implementation part. So there were 3 groups, separate groups. So we'll give only 1-to-1. I'll give you that answer also, but later, for sure. But because that is what we wanted to do. But one thing, I never knew that running experiment and identification is so difficult in a field setup. If I wanted to do combinations, so now I need to have another set of people who will get the combinations. In the combinations also, we need to ensure that either we have to make it random just to make sure. Now the question would be, it takes a lot of money because we are 1,400 per person. So you can imagine, I'll show you that we have like 1,100 drivers, almost 1,100 drivers. It's a huge money involved. And so we did some counterfactual analysis. We did not look at combination, but we looked at, can we personalize it? I'll come to that. Okay. So let's say if you're a personal best nudge, and then you have last score nudge, personal average, and then a control, which you'll use to get neutral message. Now, 3 treatment group and 1 control group. One thing is which is very important was nudged every 3rd day. And I'll tell you why it was 3rd day. It was not our design, but this was because the app was already sending a neutral message every 3rd day. So we did not touch it. We actually went to nudge the driver so that everything else remained constant and only one thing changes, the nudge. So this is how we implemented. So drivers were enrolled in the program, and we launched our app in iOS and Android Play Store and whatever is called for iOS. And what happens basically, we collected the baseline for 3 months from May to July. And everyone that point in time was receiving the message, thank you for using driver. So this was a legitimate app, properly launched with a full license from in the Google Store and Play Store. And people were enrolling. And during enrollment, they were receiving basically what are the conditions under which they can do that, how much money they will get, and what are the conditions for claiming the reward. And we randomized them after 3 months. And what happened basically, this is one group basically. So answer to your question, only one group received 1 nudge, 2nd nudge, 3rd nudge. And what we did is basically for 3 months, we kept running this. And then in October 2018, we closed the experiment and concluded. Actually, we wanted to run it for a very long period of time to see what is the long-term effect, because 3 months is very small, but we could not do it because it was too expensive to keep doing it. Yep. That's a very good question. So you're saying, am I doing this? Is there in a staggered implementation, right? So what we did basically, if you look at the co-author, one is from JD Power, and they reached out to this company, Tata, and they work with, basically they make this automotive ranking. So they work with Tata, Maruti, all Mahindra. So they actually helped us to send these messages to the drivers so that they enrolled on a particular date. And what happened basically, once they had started doing, so most of the drivers, actually around 500 drivers enrolled here. But what happened after this, we realized when we started the nudge, there are 500 drivers also enrolled after this period, but we kept them, and it helped us because we could do a robustness test that if we do not have the baseline, they come on the different times. So here we have 500 drivers who joined, but we have 500 drivers which basically joined on a particular date, and they continue to join it. And half of the drivers, they joined here, but we analyze them separately. So I'll come to the sample size. They did not have pre. So, and by the way, luckily we collected the data. And if you're doing a field experiment, please do not stop collecting data or let enroll, because referees may ask you, what happens if this happens? So what happens if the people, was it a novelty issue? What is this? What if you don't have baseline? Will that work? And we could show the robustness through the drivers. So now, before I go to the sample size, I'll tell you something which is very interesting. So we designed the first experiment, and we have to make sure that it is not having any threats. So first one is, was it a performance improvement or changes due to nudge, or is it because of the incentives? So what we did, basically, we paid every driver equal amount of money. If we had paid based on performance, then people could have argued that it is because of performance plus nudge, not the nudge. So we paid everybody fixed amount of money, single. After. So they had to keep it for 6 months. So the only condition was so the only condition for getting the money was 6 months they have to keep the app. So no other conditions. So no conditions on driving, no condition on anything. So only condition was, if you keep the app for 6 months, we are going to pay you 4,800. That's all. And after 3 months, we ran the experiments. They did not even know that they are going to be part of any experiment. Second one is effect of attrition. We're very surprised that only 4 people left the program. So after launch of experiment, and they left from all the 3 groups. Yeah, 4 out of 500. So not a big. Another thing, which is, if you are planning to do survey, don't do it. That will be my suggestion. So when we did the survey, and we didn't want to pay for it extra. So most of the drivers actually did not participate, or they put some random and that left it. But what we found, we have 44 responses, and we found 2 things. One, we know the drivers, what is their score? So we know from top 20 to 100 how much they are. Most of the drivers were like 40 to 60s in India. And we asked them after 6 months, how much do you think your score is on driving? And guess what? How much they have written? Not a single driver out of 44 wrote less than 80 to 100. So they were super confident about their driving abilities, despite seeing the scores consistently. And second thing, what we found, that we also asked, what is a good driving? And then we got very interesting interpretation of what is good driving. So if I basically overtake on the highway without touching the driver, or with a very small amount of gap, then this is extremely good driver, and so on and so forth. So that was very interesting. And we thought that the AXA study is, sorry. So AXA study also showed this, when you ask people what is good driving, then they will think and they will put something which may very interesting results. Yeah.
Technical question of the implementation, but the reason I am asking this is because treatment is a true treatment, right? So the application is on the mobile. So which means they have to pick their mobiles when they are driving. Right? So were there any checks and balances? For instance, maybe I'm taking an extreme case, but if I know that I am taking a very traffic area, prone area, for instance, I know you said that there is no incentive, but maybe kind of leave the advice from that. So they I know.
So let me ask you this question back to you. Will you leave your mobile phone? No. So switching off the app. So there is something called. So I learned a lot from this company, by the way. To go. There's something called heartbeat. They keep on checking. So if the app is basically there or not, on or not. So that. By the way, they also collected two more data points, like whether the person is using it for music or they are using for calling. What is the angle of the phone? So you can, from the angle of the phone, you can make whether it has been kept on the seat or came in the front. So like the angle is not changing much. So, it is. So, but they did not use it. But we also know about the phone usage and all. But you're right. One of the benefit of doing randomization is this can be a factor for all four of the group, not one. So if let's say 5 of these people are there, but in a random assignment, I'm ensuring those 5 people will be always there in other groups as well. So I don't have to worry about those specific behavior. So that is one of the things I loved about the field experiment part, that identification, these challenges sometimes basically don't come because you're randomizing. Does this answer your question? Yeah, sure. Not possible.
Whole experiment, this was more of a. So relatively, your betas, I understand that they don't, but on the whole, could they be kind of.
So you have nailed down a very valid point, which basically we ignore. Self-selection is not an issue, but this is conditional on people are accepting the telematics app. So basically all my results are, if you're accepting the telematics app to monitor your driving behavior, then the results are valid. But you're right. But this is not a big problem because the acceptance rates have now skyrocketed in many countries. So I don't have to convince the referees that that is going to be a very few people, those who are going to use the app. So now there are around more than millions of users worldwide for this. There are at least 20-25 companies which are making this app. Even India, there is a plan to launch. So this was basically one of the pilots these companies wanted to do. Yeah, yes, that is true. So this company in 2018, they one of the like objective of working with Tatas and others, just to test the market as well, that whether telematics will even be acceptable or not. So they are okay to measure their driving behavior, but linking it back to the insurance, that is something the companies, it will take some time, but it is going to come for sure.
Still a person, right? So their own vehicles, so they have.
Yes. And it'll come because it has come to most of the countries now, and it has advantage because wherever you will see insurance premium going up, you will see the adoption rate of this kind of technology will go up. Yeah.
Is it India?
India. It's India.
Now, people who are using this, is it necessary they are using the same?
So
two-wheeler sometimes.
Yeah. So one of the beauty of this app is based on the gyroscope and accelerometers conditions, we can identify whether the person is on a bus. We can match it with a train track. We can say whether the person is on a track, he is a passenger or he's driving. Those things you can very easily do. That also we can do, because two-wheelers vibrations are very different and the braking patterns are extremely different than a four-wheeler. They're only for four-wheelers. Yeah. And let's say there are 1 or 2 people where we were erroneously picked up 1 or couple of trips. We assume because of random assignment, that kind of error will be all 4 groups.
How do you distinguish between a passenger or a driver in the four-wheeler?
So because if you're in we are matching your driving signature. So you can identify whether that person is driving or it is completely different. Yeah.
The driving signature is obtained by the fingerprint.
No. Driving signature is like a fingerprint. This is very specific to one person. So it is based on how you apply brakes, how you do accelerations, how you do maneuver, and that's how it is generated. So if you want to kill the app, you can always kill the app. right? If you want to kill the app. So the app has basically, but we know if you have killed the app, but we did not see that coming. One of the one of the biggest challenge of these apps, if you're working with these apps, was few years ago. One of the biggest challenge was battery. So it used to drain a huge amount of battery. So that's why people never used to like these kind of apps. Now there is two things happened. One, the battery storage capacity is completely gone up. And second thing was happened, they have optimized their software significantly well. So this one uses very small amount of battery. Some of the computation, instead of doing within the phone, they just park the data and then they do it in the server. Sometimes they also reduce the amount of GPS data. For example, if you're staying in one place in an intersection and we are able to identify it's an intersection, you are on a stop for 2 minutes. You're stopping there for 2 minutes. There is no point of sending the GPS data every 2-3 seconds. So a lot of optimization has happened to improve the battery usage percentage. It uses very less battery nowadays. Which one?
The driving signature was generated using the control pre-observations or what?
When you use the app for the first 5-6 times, then it's where that is there. So what happens? Let's say one phone is used by 5 people. So what happens? Like usually people, those who own car, they also have like their own phones. So as a result, you'll not see a lot of variation. But let's say somebody took your phone, but then it will take one more trip to create it. So it will be basically, there is an accuracy threshold. If it passes that, it will basically create that your signature has been created. Okay. So we have 1069 drivers in total, but these are drivers. So Maya, answering your question, 529 were the drivers who joined before and after. Yeah. And I will not say they joined exact same moment, but within the first, within a couple of days, they joined. These are the drivers basically who joined when the treatment has already started. So this is basically, we kept the platform open. And we realized that this helped for robustness test of our result, because even if you don't have if you're randomly assigning, you should get the same result. So we have 109, 131, 140, 149 drivers in 4 groups, total 529. So what we found, so we have before, after, and we have treatment control. So difference in difference is the obvious and a natural way to analyze this data. So what we, and just to make sure that to explain you what is it. So let's say before experiment and after experiment. So before the experiment, if the control and treatment group follow a parallel trend or a similar trend, and you don't change anything other than the treatment, then any differences between the two on an average can be attributed to the treatment controlling for or the compensating for the differences which happened before the pre-existing differences. Pre-treatment differences. So basically beta 2 is the effect, and your dependent variable is the trip score, and treatment are dummies for the nudges, and controls are distance, time, etc. So we wanted to make sure that anything which other than the nudge, we wanted to control for it. Now, yeah.
Drive at least a minimum number of kilometers every day?
No. So what we did is basically we asked just one question to them when they are qualifying, that do you make at least 10 trips in a month or not? So that is what, kilometer wise, we did not ask them. Number of trips was very easy to ask people, like, do you drive at least 10 times in a month?
Or cumulative number of kilometers driven were the same, or?
Yes. On an average, so we did the balance check of all the 3 groups. So the number of average scores were very similar before the experiment. They were very similar in number of trips taken, number of kilometers driven. On an average, they were statistically almost very similar. Driver trip level.
Someday I'm
Then. Which one? Oh, driver GJ is, wait a second. I think it is origin, destination, and time. That is what. So a trip can be broken into two parts, origin, destination. So we also control for which kind of locations the people are basically traveling to.
What was the level?
Yeah, trip level. Sorry. I beg your pardon. I is individual driver. G. So IG is basically, G is the group where you are assigned, not origin, destination. J is the trip, which has origin, destination, and T is the date.
So if they were
Individual. So for a day, as many observations I can have for as many trips you take. So on an average, if I remember correctly, on a weekly basis, there were like 7 trips on an average, 6 or 7 trips on an average.
So you have two fixed effects, right?
Yes.
The individual fixed effect. So what is the second fixed effect?
Date.
The date. like-
Date fixed effect. Yeah.
Any specific city you chose?
No. But as you know, like most of the drivers were from Mumbai, Pune, Bangalore, Hyderabad, and some drivers were from Lucknow, and we also had some driver from Ahmedabad. So like the app store was open to everyone. So wherever you'll see that high density of drivers, you'll see. And by the way, we tried to look at some cities specific. We did not see any differences. Like, yeah.
One. From service provider. I missed it.
Yes, sure. No. So they are not from service providers. So basically, no. So what we made sure that they are not from the service provider, because driving for any platform is very different from driving a passenger, like your own vehicle. We wanted to only focus on drivers who drive their own vehicle. Basically, the driver are owners of their car. So we did not use it for platform. And one of the key reason why I did not do it for platform, because there are so many notifications coming to the driver from the Ola and Uber. They will completely not be able to see our notification, and also their incentives are very different. Other parameters, their incentives are more important than. So I'll give you one example. Like this company was working with ComfortDelGro, one of the companies in Singapore. And ComfortDelGro said, we are not going to take any cancellation fees from the drivers, from the passengers. So can you imagine how it backfired them? So the drivers are going to go to the passenger whom they can see, like they're 200 meters, and they will cancel that point in time. So drivers from here, if I'm as close I'm going to the passenger, I'm going to drive even faster, because I don't want to lose at the last moment. So what I was trying to say, that these kind of problems from a rideshare company can create a huge problem for us. So that's why we only looked at owned cars. Yeah. So what we found, not all nudges work. So, and this is something the referees also liked. So basically, that's why I was saying in the beginning that I'm not a proponent of nudges. It has to be designed well. But we should definitely, as an academician, try to think why it did not work when we anticipated that it will work. And I'll come to that. And then we found that only average and personal best nudge work. And they improve the trip score by 4.5 points, which is going to increase the inter-accident time by around 21 months, which is quite good amount of number for insurance companies to care for. Another thing, you'll realize that although our treatment is orthogonal to outcome because of the random assignment, one can say, oh, you don't have parallel trend, or how do you test? We visually test it, but you can always get into trouble. Let's say the parallel trend, you're not able to convince there is a parallel trend. So what we did is we used synthetic control method, which is basically does not depend on parallel trends. So this is some sort of a robustness test. And finally, you might have noticed that the score is a discrete variable. So although we have done OLS here, again, there will be a argument whether is it a good method or a better method, but we saw that there are, so Woolridge paper is there, which shows that they are equivalent. And we also confirm that by ordered logistics, which is more appropriate for this case. Difficult to interpret, but easy to, more appropriate. Yes, yeah. So Maya, I think you should work on this project. You have very good sense of this. So what happens, this company works with like across the world, and every for every country, they have made a profile that what is the score and what will be the inter-accident time. So we basically used the company's help to put this in the plot and got a sense of around 21 months was the time. And we also have to look at like how good the drivers are, how bad the drivers are. So for example, at every time, 4.5 at 90 score is not going to give you 21 months, but 4.5 at a very low score is going to give you higher value of inter-accident time. So based on India's profile, this was we found out from the company's extensive data. Next. So on an average, if we improve driving performance, one can ask like, are these drivers becoming more zigzag or more, there is a high variation in their performance, or they also become a lot more consistent in driving? And we found the same. So these two nudges actually improve the consistency, which we measured by coefficient of variation, that they also become consistent in their driving. Now, when you're working on a problem which is having a policy implication or it is affecting other drivers, like drivers is something not private, so we drive on the roads, we affect other drivers. So we wanted to understand beyond the average effect, because average can be a sum of a negative and a positive, small negative and high positive. But the problem is that driving has negative externalities. So if with our experiment we make somebody drive worse, it is going to affect other drivers on the road as well. So we wanted to understand, at least with some accuracy, that do nudges deteriorate performance of some drivers? And second, do we see this average value across drivers, or do we see different values? So is there any heterogeneity in the treatment effect? And lastly, we are going to ask if there is heterogeneity in the treatment effect. And coming to Maya's question, can the firm personalize nudges? So can I not give one nudge to one driver, but I can find out your profile and then give a different type of nudge, which can be more effective to improve your performance? So I'll go a little quick here in respect of time. So there are many methods available econometrically. So you can do interaction effects, you can do subsample analysis, or you can look at nonlinear DID. But look at interaction effects. In interaction effects, which variable should I take for interaction, right? Or if you're doing subsample analysis, one of the question is, where do I split? Should I split in the mean or median? And that's the question. So what we started looking at some new methods that point in time, developed by Susan Athe and her team during her stint at Microsoft, which is called machine learning for causal inference. And this is called generalized random forest. And generalized for random forest can answer all three questions, but it has a couple of benefits. One, we don't need to find out the variable where across which the heterogeneity of the treatment is there. It automatically identifies that pattern. And by the way, if you have a chance, please do look at this paper GRF. It is very cool in terms of identifying heterogeneity. And if you're doing an experiment, it can give you even more patterns. Second, many features are similar to random forest. So if you understand random forest, understanding this is not very difficult, like partitioning. And what is best part of GRF is the honesty. What honesty by mean to in random forest, you build trees and you estimate the effect using the same data. But here it is not the case. You split the data, and one set of data is used for building trees, another set is used for calculating the effect. So this is called honesty. As a result, one of the biggest advantages, you get the effect size which are asymptotically normal. Means you can calculate the confidence interval, you can calculate the p-values, everything like a linear regression, which is easy to interpret. And finally, they are very efficient to run on even a small memory machine, and it will tell you across which dimension there is huge heterogeneity in the effect. So I'll show you visually how does it look like. So basically, take the samples, split into two. This one is only for creating tree. This is only creating the effect size. And you do it for B times or an average over several trees to you get the generalized random forest outcome. So intuition is basically split the data into two equal parts. For each tree, identify the treatment effect for each leaf, and then you calculate the average treatment effect. So I'll not go into the details of this one, but I'll show you something which is interesting outcome of applying this. So one question we wanted to ask is, driver has externality, which is negative externality. Do nudges make some people worse? And what we found that 95% confidence interval for the predicted treatment effect for average and personal best nudges all above 0. So at least with some confidence, we can say we did not make anybody worse. It was not the case with last score because it contains 0. So somebody made little improvement, somebody did not improve, and on an average, we don't see any effect. Next thing is I'm showing you one application of looking at heterogeneity. So let's say I wanted to see if the baseline ability or baseline performance of the driver pre-experiment and want to see how did they perform. So here you can see on the x-axis for 3 nudges, I'm putting the baseline performance and I'm looking at the treatment effect on the y-axis. You will see the drivers who were basically not good drivers actually benefited the most. They also had the room to improve the most, but they also improved. Same as for personal best nudge, average nudge. But if you look at last score nudge, you'll see that it contains 0. So statistically, there is no effect for last score nudge. Now, if you look at companies actually care for 2 dimensions to understand the heterogeneity in the treatment effect. One is how good or bad a driver is when they join the program. And second, how well or how much they engage with the platform. Basically, how many times they look at feedback. So you can say the feedback seeking performance. So these are the 2 parameters, by the way, eventually came out also from generalized random forest spread across these 2. So the intuition of the companies are right that these are the 2 where we see maximum heterogeneity. So which drivers basically, so if I plot on the x-axis, drivers baseline performance, in y-axis we put how often drivers look at their performance and examine it. We found that drivers who are low in performance and frequent feedback seekers actually improves the most with the nudges. That's just quite intuitive. What is not very intuitive is, so if you have to take one slide from the entire talk today, I'll tell you this is the slide. So I plot the driver's baseline performance on x-axis before, how often drivers seek feedback, and what we found the following, that drivers who are low performing but high feedback seekers perform better with average nudge, which is also very intuitive because their personal best will be too difficult for them to achieve, but average they can beat it at least sometimes. On the other hand, if they are already high performing but they don't want to look at feedback, we found that personal best nudge actually motivates them more. Lastly, we do not see any differences in these 2 corners. So this is coming back to Maya, your question, that we do not look at the combination, but this one gives us a tool how to customize the nudge or personalize the nudge based on these 2 dimensions. So basically what you do, you look at your driver's baseline performance, you look at how frequently they interact with the app, and give the drivers who are in this corner personal average nudge. This drivers give them personal best nudge, and the others you can give either of them. This is going to increase the effect size further 11% back of envelope calculation if we do that. So overall, if you look at that, this I showed you so far what was the average effect, and I showed you that how it can be personalized using a new novel generalized random forest technique. And now I'm going to show you why drivers actually improve performance. So let's say you have a belief about your performance or your driving behavior. I give the nudges, it sets a reference point, and it set you and help you set goals. Once you set a goal, you exert effort and you look at your trip score, which is your outcome. And then you update your belief. So initially you can think of, I'm very good, but you see the actual score and you keep on looking at this. Now, this reference point can have variation based on which nudge group you are. And what we did is we try to see that if this variance is driving the result. So what we did is I'm going to show you a very complicated. So what here I'm going to show you basically using the field experiment data, we can see if the variance is driving this result. So what we did, I'm going to show you a complicated table, but just stay with me. So here basically there is average nudge, which has low variation. We have last score nudge, which has very high variation. So in average nudge, if I look at the 90 percentile, basically the top where there is a very above 90%, where we see very high variation, low variation, you will see here, very high variation, you will see average nudge does not have an effect. So if I increase the variation in terms of looking at above 90% or where the variation is very small, using last score, we see the effect exist. That means the variation, we can, with some confidence, we can say the variance in the reference point is driving the result. Meaning basically, so just to give you a sense of what this slide is doing is take a subsample and look at subsample within the average nudge, which was working earlier, take when there is high variation and we see the effect vanishes. Look at the last score nudge where there was no effect. Look at only places where last score has very low variation. There we see the effect. So that is how we establish that small variation it can give you is one of the driving mechanism behind the results. So just to give you a very intuition of this, imagine that I'm a PhD student and I talk to my advisor, and my advisor every day says that you need to work hard, you need to work hard, you need to work hard, at least 10 times, and once I'm okay, did well, work hard. If I get this consistent message, I'm going to believe that message and one may work. But if my advisor says in the morning you're doing well, next time it says you're not doing well. In the morning it says we're doing well, not doing well. So if there is a high variation in the feedback, we may not be able to motivate our C to see any effect of that. So basically it shows that if you are providing a nudge, it has to be low variation. If you put very high variation in the message, people are going to get confused and it may not have an effect. Yeah. With a lot of variation.
Doesn't matter. Keep getting these feedbacks for that
Yeah.
period of time. Perhaps you're trying to improve for some time and then you lose interest.
Absolutely. So you have made a very good point, because if I claim that after 3 months, if I run it for 5 years, it is going to have the same effect, may not be the case. You're right. So that is where we have to be very pragmatic that how long it will work. In this case, we found that for the 3 months period, it was consistent, but it is possible that after 3, 4, 5 months, it may not have any effect either. And there could be many reasons. Either I know what I'm going to get, so my guess is as good as the score. I also learn. Second, I may even not start trusting the score. So that's why one of the things I realized that for the nudges, anyone who is working on nudges, we have to keep on evolving and changing it. And the novelty effects also goes away, right? If I seeing it continuously, same thing, I may be excited for some time and then I may not be. So you're right. I think that's a very good point. And unfortunately that I did not have the answer, like how long it would have worked. So that's why I was very interested in running it for a year, but I had the job market and also had to write a paper. So it stopped and also ran out of cash.
So even if it's not a knock-on to change the baseline to what it was, that's a...
So after some time, it becomes basically there is no change. Yeah. So there also with synthetic control, we could see that the trend is basically almost parallel, like they move to a different level. But your question is very interesting, because if I would have applied to these drivers again, I will not see any difference, because they have already improved and reached some level.
Learn how to drive, learn all the best practices, know how to make a turn, and then maybe a year down the line, I have lost some of those, probably forgotten. So if I keep getting those nudges, perhaps I'll remember, perhaps I won't care.
Yeah.
That's interesting to see how.
Yeah.
Because I can relate. When I first got a device, I could see quality of my sleep.
Mm-hmm.
Then I would diligently every day I would wear
Mhm.
device of the touches.
Mhm.
But then 3 months down the line,
Yeah. So that is this is one of the most beautiful part of human behavior research, that there is no end to basically improving, and there is no end to how you design these. So I'll give you one very interesting thing, which I was also sharing. The Australian government is doing a very similar program where they work with telematics company, give drivers feedback, because in Australia, there is not much of public transportation. So everybody drives. So you're driving and the drive distances are very long. So what they are doing this intervention where they are providing, after every 3 months, there is a in-house training where they ask for reflection and other, and then they change the way. Like now I want to, for example, look at if there are accident prone zone, please let me know beforehand so that I drive better. So on and so forth. So lot of other interventions. But you're right, like this is not a one thing which will fix everything. So we have to do this, then do something else, then keep doing something else to keep on improving. And eventually, like everybody will reach to their like the best, I can say. But beyond that, that best may be very low as well. So we can't do much there. But yeah, you're like in respect of time, let me show you one last thing so anyone who is working on field experiment, sometimes I thought as a PhD student that, okay, a field experiment is done, results are good, it shows an interesting story, referees will be very happy, it will be accepted very well. So what the referees ask, you know, can you guess what did they ask? Like we have this part, we have convinced them. Any guess what they asked? Yeah, so that is what they ask us, and we said we don't know because we like we had to shut down the app. It was expensive to hold it, but they asked us, you know, can you show in a different task if this is going to work? So if you nail down identification, if you nail down mechanism, if you nail down then what is the generalizability of this result? So they asked us to do a lab experiment. What happened? We wanted to and they said, can you show us? They actually exert more effort after getting the nudge. So we wanted to do a lab experiment. So we actually, Ola has a simulation system where they train the drivers, or there are some places where they have something. We reached out to them. They said 1 hour, one driver, one session, one trip, 300 rupees or 500 rupees, something like that. They mentioned. And then we realized that we wanted to do it, to put a simulator, and because we don't know which task I should show. Driving is very different. I cannot put it in a lab. So the best condition is I can use a simulator. And then I realized it's very expensive to run simulator, and then COVID hit. So we could not even run any lab experiment. So we did an online experiment. So this is a very simple task. There's a slide. It is called slider task, and this is developed by Jill and Provis. It is very simple. I'll tell you that what is the price of the item, and all the dots will be here. I have to move the dots to match the price. So you move the dot. For example, it is 1. So I slide it to 1. If it is 4, I slide it to 4. So this is called sliding task. So this task is very well accepted as a real effort task because you're doing real effort. So what we did is basically we ran this experiment with similar nudges, but we had to make some changes. Can you spot the changes here in a mechanical Turk when we did it? And can you guess why we have done that? Exactly. So in MTurk, the entire experiment, 30 rounds are going to happen in 20 minutes. They may not even notice what is the nudge here, may not read, but at least this will tell them is good or bad. And you won't believe the referees did not put any problem for us. They accepted it. They said that this salient you can make with bold and all, but you cannot ensure people are reading it. But this at least shows that they're moving or not moving. So what we did is basically we did this experiment and we replicated the results. So basically here the effect size is negative, means the time to basically do the task shortens. And we generalize on finding to a non-driving setting. So in summary, what I showed you today, that nudges can be effective in improving driving performance and can be generalized to a non-driving task. Not all nudges are equally effective. Personal best, personal average work, last score does not. And the mechanism that I showed, like potential mechanism, is the variation in the reference point. And it not only increased the average performance, but also increased the consistency in driving, which we measured through the coefficient of variation. And performance improvement are driven, as we showed in the MTurk experiments, is in the changes in effort. So it's basically the real effort changes in response to the nudges. And by understanding, this is the most important finding, that by understanding the heterogeneity in the treatment effect, we can personalize the nudges. And one of the benefit of doing a personalization is basically it can be a stepping stone in designing optimal dynamic nudges. So most of the times you'll see a lot more static nudges, but I think if we know where you are, I can actually do optimal dynamic nudge, like what should be the next nudge I should show it to you. So in summary, this is the summary of the talk. If you have any question, any feedback, just let me know. So just to give you a sense of what I work on, so I work with most of my research are with industrial collaboration. So I work with last mile delivery companies. I work with ride hailing companies. I with health tech. And my focus of the task is basically behavior and improving behavior as a lever to improve performance. And recently I did two field experiment, one on recommendation system and one on health tech platform where we make the prescription safer. So if you are interested to know more about any of my projects or any of these, I'll be mostly here after the talk. Let me know. And thank you for having me. And thank you, Devjit and IIMA Ahmedabad and CTL for inviting. And I'm really happy to be here. Thank you so much. Okay, so one of the question, let's me read. Winning is a major part of sportsman motivation. What is winning for a driver? So this is a good question. So sportsmen, if you see, they are not competing every single day. They are practicing most of the time. So when I beat my personal average, is same like I'm treating my drivers as a personal best. So that is the answer to the first question. Then, was there any specific selection criteria for 3 treatment and control groups used for the field experiment for candidates? So I think I answered this question. So they have to make fix at least a few number of trips, and they should own the car, and time to reach destination not same due to many uncontrolled reason. What if the road is empty that time? The score is high. Do you consider score as best score? Oh, this is a good question, Parvez. So basically, since you're randomizing into 4 groups, all of them will have the opportunity like this. So that will average out. It will not affect the results. And was a beta version of the app launched in the market since it was Play Store for 3 months only? Was a beta version. My guess is it was a full-fledged app. So this app basically is already there in several other market. It was tailored for Indian for this specific experiment. Was the ratio of male-female candidate in the sample size? Oh, that's a very good question. Most of them were males. So around 9. So we asked them to, so IRB did not allow us to forcefully collect the data for like age, because we are all looking at the GPS and all. So we knew that most of the drivers were from 25 to 54 or 55 age, whatever data we had. And male-female ratio was very skewed towards male. Most of the drivers were. Yeah.
Like age and which nurse works for them, something like that.
We did not do that because the age data were not available for all the drivers. So that was, but that could have been a, yeah, you're right.
But the driver's signature would be very different.
Yeah, that's true. That's true. With age, right? Yeah.
Also with the
Gender also, yeah. So we actually have a app ready for last 1.5 years because we could not run it because of Corona. We have a new app ready with social versus self-referencing, and we want to run it in Washington, not like Seattle, because all the students drive there. So we're planning to do that, and there we are going to have like male, female. We'll try to incorporate like equal number, and maybe we'll be able to see the effect of gender. Yeah. Yes.
Was years of driving experience also factored in this?
No.
Would it not make any difference?
Because on random, because the drivers were randomly assigned, that will be basically average out across all 4 groups. And this data is derived from using a phone, and the phone is looking at 30-40 meter accurate, not exactly how much accuracy of the result is achieved during this data study. So rhythm, I think one of the if you're looking at 30-40 meter accurate, you mean the GPS, but GPS, the telematics app do not work on one instance of data. So every 5 seconds it is pinging and triangulating to find out the correct road. So if it goes out of the road, it will bring it back to the road. So basically this accuracy doesn't matter. And by the way, one very specific question was asked in one of the seminar I gave, that what if your app is very bad? It doesn't matter because I'm doing the same app for all the 4 groups. So yes, it is conditional on the app, but basically it is not going to affect significantly. And this app, by the way, was tested in several other countries, including India, before it was launched. So they ran it for a very long period of time. How was the driving signature taken by drivers monitored for a certain duration? Yes, that's correct. Yeah, Srishti Arora. Also, Srishti Arora is my PhD student from NCR. And I did not pay her to write this nice comment. Okay. Yeah. So with this, I'll conclude the talk. Thank you for having me. And if there are any questions, any more, I'll be more than happy to discuss. And thank you.